Okay guys, so in the last video I showed you how to draw these guys. And I wanted to show you, remember that everywhere that there's not a paired electron, that's where we're going to form bonds, okay? Argon has all of its electrons paired up, and so it doesn't need to form any bonds. So this rule is called the octet rule. When all of your electrons are paired, you will have 8 electrons in the last energy level, and that gives stability to an atom. And why 8 is the magic number is actually a really complicated question. Just go with it. The exceptions are hydrogen and helium. They only need 2 electrons in order to be stable and happy and not react with everything that comes along. So atoms are going to share their electrons in order to get to 8. So this idea involves what are called Lewis structures. And so Lewis structures are pictures that represent how valence electrons are shared between atoms in a covalent bond. So we're going to take those dot diagrams that we drew, that I just showed you, and we're going to put them all together into molecules so that everybody has 8 electrons. You will put the dot diagrams of 2 atoms together. You may have to move your single electrons in order to get it to work, but it will all work. So the steps. Arrange the atoms to show that they're bonded together. Put the number of dots needed for each atom. You may have to move unpaired dots around, but that's okay. Connect the dots to make pairs. Connect the dots between atoms first to form the bonds. Connect pairs of electrons belonging to single atoms also. So I'll show you that. It's basically we're going to play connect the dots. And then count the number of pairs, which is your lines drawn. Okay? When you're trying to figure out what it's supposed to look like, the central atom, or the one that's in the middle, is usually written first in the formula. Hydrogen can only form 1 bond. Carbon is always in the middle, and that's going to be really important for us in the next lesson, but it's important today too. Okay, so I'm actually going to escape my screen here. Oh, don't look at that, don't look at that. Okay, I'm going to escape my screen so that I can kind of show you what's going on here, okay? Because the periodic table is really helpful. So we have hydrogen and chlorine. So hydrogen is all the way over here in group number 1. So hydrogen only has 1 valence electron. And remember, it really only needs 2. So I'm going to scooch you back over. So hydrogen has 1 valence electron. And I'm going to add to that the electrons for chlorine. Chlorine is here in group 17, so it has 7 valence electrons. Well, 1 plus 7 equals, you guessed it, 8. So that means I have 8 valence electrons total to work with, okay? So what I'm going to do is I am going to draw hydrogen, and I'm going to draw chlorine. I like to do a cursive L, and it'll kind of make sense why here in a minute. But you can do a regular L if you want to do regular L. I will tell you that if you want to handwrite this and upload pictures, I'm totally cool, because drawing on the draw tool, it's kind of fun, but it's after a while, it's kind of annoying too. Okay, so I'm going to make my dots a different color. It's different. Ooh, that's pretty blue. We'll do that one. Okay. So hydrogen has 1 dot. Normally I would put that 1 dot up here, but I'm going to move its unpaired dot to the center. Okay, that'll make sense here in a second. Chlorine has 7. 1, 2, 3, 4, 5. I'm going to leave this one unpaired. I'll show you why in a second. 6 and 7. And so the reason I'm going to leave that one unpaired is these two, if chlorine can grab onto hydrogen's electron and hydrogen can grab onto chlorine's electron, then they can share them and they can both have 2 electrons there. And so I drew a line between those 2 shared electrons. Now anywhere where you have unshared electrons, so like these guys, I'm going to connect those lines too. So like I said, we're going to play a big giant game of connect the dots. So that's 1, 2, 3, 4 pairs of electrons. Okay? to figure out how many pairs of electrons you're going to draw, you just divide by 2. So 8 divided by 2 gives us 4. And the reason we divide by 2 is because there's 2 electrons in a pair. Mrs. Miner? Let's do this again. Okay, so I'm going to switch back to purple for my atoms so it all's matchy-matchy. Okay, so I have 2 hydrogens this time. See that? Well, each hydrogen gives me 1 electron, so I'm going to put 1 plus 1 because I'm going to end up drawing 2 hydrogens. Oxygen is over here in group 16, so that's 6 electrons. Bloop, come over here. So I'm going to add in 6. So 1 plus 6 equals 8, right? Okay. So I'm going to have 8 electrons by the time I'm done here. So I need somebody to go in the middle. Usually it's the first one written, but since hydrogen's so little and he can only make 1 bond, I'm actually going to put them on the outside. So hydrogen and hydrogen, and I'm going to put oxygen in the middle. So the goal is to get all of our atoms bonded together, okay? So each hydrogen has 1 valence electron. So remember, I'm going to put those unpaired electrons towards the middle where they're going to form their bonds. Oxygen has 6 unpaired electrons. 6 valence electrons. I don't know where I got unpaired from. 3, 4, 5. I'm going to leave that one unpaired so it can bond. And then number 6. So I'm going to connect all of my lines. So now hydrogen and oxygen are going to share those electrons and make a bond. So this is called a single bond, by the way, a pair of electrons that's connecting 2 atoms. And I'm going to put those together. And then these electrons over here with oxygen that are not shared, I'm going to put them together. So I ended up drawing 1, 2, 3, 4 lines, which is 4 electron pairs. Okay, so for those of you who are like, do I really have to draw all the dots? I'm going to show you a shortcut. If you don't like the shortcut, don't use the shortcut. So for this one, for nitrogen, I'm going to go back to my purple so all my atoms are the same color because that matters to me. So nitrogen is in group 15 and there's 5 valence electrons. I'm going to put this out here because I'm kind of running out of space. And then we have 3 hydrogens. Well, we know because hydrogen's over here in group 1 that it only has 1 valence electron. But there's 3 of them. So each hydrogen will give me 1 electron. Ooh. I hope you are better at drawing in this than I am. I don't know. So 5 plus 1 plus 1 plus 1, it's all going to be 8. Maybe not. Maybe this will just be the fun part of it. I don't know. Well, remember, we're dividing by 2 because everything's in pairs. So 8 divided by 2 was 4 up here. Well, 8 divided by 2 would mean that I'm going to end up with 4 pairs of electrons. Okay. So that kind of gives me an idea of what I will look like. So I have 1 nitrogen going in the middle because it's written first. Hydrogens on the outside, and there are 3 of them, and I know that because of this little 3 that's down here. Ooh. And third one down there. So notice I'm putting everything on like the sides first, and then I do the tops and bottoms. Okay, so we're going to put in our electrons. So each hydrogen had 1. Our nitrogens had 5. Now, I'm showing you this because I knew I was going to have only 4 pairs. And those 4 pairs are going to go to connect the atoms first. 1, 2, 3. And then I'm going to connect the dots on top of the nitrogen for the 4th pair. Okay. For carbon and the chlorines. Sounds like a band name from the 70s, but here we go. So carbon is in group 14, so that's 4. Oop, 4. Chlorine is in group 17, so I'm going to add in 7 4 times because there's 4 of them. So plus 7 plus, that's a bad plus sign. Hopefully you get the point. Plus 7. Oh my goodness, people. Don't fire me, please. Plus 7. So 7 times 4 is 28. Plus 4, that gives me 32 electrons. I don't really want to draw 32 electrons. I don't want to draw 32 electrons. So I'm going to go ahead and put my atoms in here. Carbon, and I told you I like to do the cursive L when I do the chlorines, because sometimes these little pairs of electrons can look like an L, especially if you're not super careful. Okay, so I'm going to go ahead, come back here, give me my blue. So I'm going to go ahead and divide 32 by 2, right? Because that's how I get the number of pairs. I know we did a big jump. We went from 8 in our molecule to 32, but just go with it. And that comes out to 16. Okay? So I'm going to have 16 pairs of electrons in here. So what I'm going to do is I'm going to connect my atoms first. 1, 2, 3, 4. Once my inside atom, or once all my atoms are connected, I'm going to take care of my outside ones next. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And when I'm done, everybody should have 4 lines around them except for hydrogen. If I have any extra atoms, extra electrons, I won't have extra atoms. If I have extra electrons, they go on the middle atom. So like we had an extra electron here for nitrogen, it went on the middle. We had no extra electrons here for oxygen, they went on the tops and bottoms. Okay, I hope this helps, guys. So we're going to talk about organic chemistry next, which is going to be the bulk of what we talk about for the rest of this unit.